Good morning, New York, and welcome back to CCNY Educates. Today we will have two special guests from the Science Department, Mr. Jason Ortiz and Ms. Naima Hawk. They'll be explaining to us about something very near and dear to us, the Earth.
Hello, thank you for having us.
Welcome. Now, what do you have to tell us about exploring the Earth's layers? To begin, exploring the Earth's layers, we should understand that the Earth can be divided into many kinds of layers, depending on your dividing factor, of course. We will be focusing on the seismic waves distinction, which tells us that the Earth's interior consists of four concentric shells, which are a thin outer crust, a mantle, a liquid outer core, and a solid inner core, as pictured in this. As you can see, each layer can be located at certain distances. The temperature of the layers varies as we go deeper into the Earth. Up top is the crust. It's the layer we are standing on, the shell of the Earth. The crust is the thinnest, coldest, and most brittle of all the layers. It constitutes just 1% of Earth's total mass. The temperature of the crust varies considerably, with the hottest recorded temperature being 70.7 Celsius in the Lut Desert in Iran, and the coldest temperature being recorded in the Soviet Vostok station at the Antarctic Plateau at negative 89.2 Celsius. The crust composition is dense solid rock and relatively light elements, especially silica, aluminum, and oxygen. The thickness of the crust varies at different areas of the Earth. There are two types of crust, the oceanic crust and the continental crust. The oceanic crust varies little in thickness, generally extending to about 5 kilometers. The oceanic crust has a relatively high density and is composed of mostly basalt. Its density ranges from 2.8 to 3 grams per cubic centimeter. The thickness of the continental crust varies much more, but averages about 30 kilometers. Under large mountain ranges, it can range up to 100 kilometers. The continental crust has a relatively low density and is composed of mostly granite. Its density ranges from 2.6 to 2.7 grams per cubic centimeter. The crust is broken into parts known as plate tectonics, which moves at a slow pace between 3 to 5 centimeters a year. The tectonic plates will meet each other and cause earthquakes and volcanoes on the surface of Earth's crust. These plates float above the Earth's mantle, and it's believed that the convection in the mantle causes the plate to be in constant motion. The crust is very thin compared to the mantle. Here's an animation that can show us how much larger the mantle actually is. The mantle is Earth's thickest layer and makes up 84% of the Earth's total volume. It is almost 3,000 kilometers thick. It is dense, hot, and viscous. It is made mostly of iron, magnesium, and silicon. Its temperature ranges from 1,000 degrees Celsius to 3,700 degrees. The mantle can be further divided into the upper and lower mantle, with the upper mantle containing two distinct regions, the asthenosphere and the lower portion of the lithosphere. The lower mantle is sometimes referred to as the mesosphere. These three regions are included in the chemical distinction of Earth's layers, which we won't be going further into because we are focusing on the seismic distinction. Now, onto the core.
The outer core consists of iron and nickel, which is in liquid form. It will be below the surface at 5,180 to 2,880 kilometers, or 3,220 to 1,790 miles. It will be heated by the radioactive decay from the elements of uranium and thorium, which is shown in the image. The outer core is it's where there's liquid. It helps maintain a breathable atmosphere and environmental condition that's favorable for the ecosystem. The liquid will create a big turn in turbulent current. The motion will produce electrical currents. The electrical currents which are not visible to the naked eye, will cover the entire Earth and space, which would generate a magnetic field, which is shown in the figure. It reverses every 200,000 to 300,000 years. Without the magnetic field, we will be stripped of life, such there won't be gases and water. This is still happening in Mars. The Danish geophysicist Inge Lemon used seismic data to be the first to prove that the inner core to be solid. The inner core will have a solid metal ball of a radius of 1,220 kilometers or 756 miles. The size can be compared to the moon, which is 3/4 of the size of the moon. It will have a liquid core. It will be located between 6,400 to 5,180 kilometers or 4,000 to 3,320 miles. It will mostly consist of nickel and iron, which are dense. The spin of the inner core will be greater than the Earth. The heat will be between 5,400 Celsius or 9,800 Fahrenheit. It reaches almost the same heat as the sun. The pressure is 3 million more than the surface of the Earth. The temperature is way above the melting point of iron. There is not a lot of information we have gathered from the inner core due to the equipment that hasn't been developed yet, and scientists will be crushed by the pressure produced in the inner core and the high heat. Scientists are still exploring the Earth and its layers and finding out more about it every day. Who knows, maybe technology in the future will help us travel the inner core and outer core. This is the bibliography, also known as the references. Thank you for joining us at CCNY Educates. Until next time.